So, good afternoon students. Today we are going to perform one more experiment called figure of merit of a galvanometer by half deflection method. What is it? Figure of merit of a galvanometer by half deflection method. So, the circuit connections goes like this. The positive of the battery is connected to the galvanometer, any one end of the galvanometer. From there, we are going to connect to the one of the standard resistance box. The range varies from 1 ohm to 1000 ohm. The range of the resistance box here is 1 ohm to 1000 ohms. Standard resistance box, variable. See that all the knobs are tight, otherwise they are going to add up. You know that the series combination, the resistance will get added up. So that we are going to make it, all the knobs are tightly locked. Then the other end of the resistance box is connected to the K2. This is K2, and when K2 is opened, nothing will happen. Okay, K1 and the other end of the K2 is connected across. This should be tight to the galvanometer of the other end, and from there K1 is connected, which has to be closed, tightened. Here also the circuit connection has to be connected. Here it is connected to the high resistance. Which resistance? High resistance. The range varies from 1 to 10,000 ohms. The range varies from 1 ohm to 10,000 ohms. Here the knob should be tightly fitted, otherwise you will get it, the series will be added. And the other end of the resistance box is connected to the negative terminal of the battery. So we will see the deflection here, how we are going to do the calculation. The calculations can be performed like this. First, the tableau column goes like this. Where is the tableau column? Okay. So, we are going to perform this experiment. I am going to remove some, say, 5000 ohms for the safety. I switch on the battery. You can see there is a deflection in the galvanometer. There is a deflection out of the scale, it is showing, out of the scale. So I have to reduce it. So I am going to increase the resistance value. So I get here even deflection. I think it is 24 is the reading here. The theta is shown to be as, division is taken to be as 24. So I write this here. How much the resistance has been removed here? The resistance are removed to be as 7000 ohms. How much? 7000 ohms. What was the deflection I got here? 24. Always this has to be even. Theta, the second column should be always in the even. Why? Further, if I divide 24 by 2, I will get 12 divisions. Here I should see 12 divisions, and I should unplug the standard resistance from here. When I put K2, when I put K2, you will see there is a zero deflection in the galvanometer. Did you see that? You got zero deflection. The moment when the K2 is closed, you will get the galvanometer is the zero deflection. So from here what I do, I am going to unplug the resistance value of the given galvanometer. How much I should get? How do I come to know that? 24 divided by 2 will be 12 divisions. 12 divisions should be on my galvanometer. That will give me the confirmation of the high resistance. That is what is the resistance of the galvanometer. This will come by only by trial and error method. Theta should be 12 divisions. What is the resistance? Yes, I got 80 ohms. You should write here 80 ohms. Take it down. Again, I will unplug this. I will close this one. I will cross check. Is it for the same I am going to get? I will unplug. Now I am going to remove some more 2 more 12,000. So now it is on 28 or how much? 10. Is it 18th division? You check it out. 18th division.
Yes, sir.
18th division?
Yes, sir.
So if I take that one, what is the resistance here? 5000. plus 2000 plus 2000. It was 9000 ohms. So what is the division there? 18th
18th,
division.
sir.
So I'll close it. The galvanometer should show zero deflection.
Zero deflection.
The
Yes.
galvanometer should show zero deflection. So I will cross check. Previously I got how much? 18, right?
Yes,
18 divided by 2 is 9. For 9th division I should get 80 ohms. Shall I check? That will get 9th division is there, you check it. Is it there on the 9th division?
Yes, sir.
So what is the resistance I have taken here unplugged? 50, 20 plus 10. Total 80.
80.
So again I got the correct reading 80. Consistency is there.
Yes,
One
sir.
more reading we'll take for the calculation purpose. We'll do it. We'll close this. We'll remove one more 1000, or you may take around 500 or something like that. I remove 1000 here. Total 5 plus 2 plus 2 plus 10. It is 10,000.
10,000.
So when I remove this, I will get around how much? It is around 16th division, I think. You see the 16th division, it is there?
Yes, sir.
16th, or still it is less or greater?
Sir, it's 16, sir.
16th
Yes,
division.
sir.
So 16th division is there. So what is the range I have taken here?
10,000.
10,000. And I got
16th
16th division. I will put it this K2. It becomes a zero deflection. I remove 50, 20 and 10. So what I should get? 16 means how much? 8 I should get.
8.
Is it on the 8th division?
Yes, sir.
Is it on the 8th division?
Yes, sir.
So here we have completed the practical part of the experiment. Remaining is the theoretical calculation we are going to perform. So how do we do that? By whatever the things we have unplugged, we will plug it out and we are going to calculate the value of what is called G and K. So how do we calculate G? We calculate G is equal to R into S divided by R minus S. R value is how much? 7000 ohms into S value is how much? 80 divided by 7000 minus 80. How much we'll get? We'll do it. So 7000 into 80 is equal to
5 lakhs.
5 lakh 60,000. We are not writing the amount here, we are writing the resistance value divided by how much we'll get?
6,920.
6,920. So if I take the ratio of it, 5600 divided by 6920. So what was the resistance? We got 80 ohms, but we are getting 80.92 ohms. Units are very important here. You write 80.92. This will be very helpful to calculate in what is called figure of merit. Similarly, I will calculate for second one. R into S. Always you try to practice this one. This becomes a habitual for you. R is how much? 9000 here into how much I got? 80 divided by R minus H is 9000 minus 80. How much I will get to check it out? 9000 into 80 is how much? How much? 7 lakhs 20,000 divided by
7,920.
9,000 minus 80. You will get 8,920. I will divide it. 8,920. How much I'll get? See, 80.71 ohms. Units are very important here. G is equal to R into S divided by R minus S. Always try to practice like this. So you'll get 10,000 here into 80 divided by 10,000 minus 80. So 8 lakh. Okay. No, 80 lakhs also. Divided by
9,920.
9,920. So 8 lakhs alwa divided by 9,920. You will get
80.64.
64 ohms. So you write the column here 80.92 ohms, 80.71 ohms, 80.64 ohms. We got 80 here. Now we want to calculate K value. Like this only you practice it, you will get K value. What is the formula? E divided by R plus G into theta. What is here? EMF is taken to be as 2 volts. So I have given already the EMF voltage is how much? 2 volts here. So take it 2 voltage divided by R is how much here? 7000 plus G value is how much here? 80.92 into theta. Theta is how much? 24. So this is how we get ampere per division. So according to the given equation, what it is says, the current I is equal to what? I is proportional to theta. See, the point galvanometer deflection in the galvanometer is directly proportional to the current flowing through the point galvanometer. So this proportionality constant is K. K is equal to theta. So I is proportional. I is equal to K theta. That's what we get it. So what is the value of K? K is equal to I by theta. What is, according to Ohm's law, V is equal to I into R. Correct now? Yes, I is equal to V by R. So what is V here? EMF. R is what here? R plus G. So this whole combination act as V by R into 1 by theta. That's what he is meant to say. This is how we get the formula.
Yes, sir.
Okay. See, Ohm's law is only the main reason for us to calculate all these things. If Ohm's law is not there, nothing is there. Okay. So we are going to perform the one calculation. I'll show the K value. Then remaining all remains. You can do the performance calculation. So here I've taken 2. Okay. First I'll multiply this one. 7000 plus 80.92. Okay. Into 24. So how much I'll get? 2 divided by 7080.92. Step by step you should write like this only. 2 divided by, if I multiply, how much I'll get? 16,994.2.08. This I should divide it. 2 divided by 16,942.08. See, some of my students will do mistake while putting the powers. There are 2 methods to write. Either it is better, I request all my students to write the numbers like that only. 1, 2, 3, 4, 11, 7, 6 ampere per division you write. Or you can write it as 1.176 into 10 to the power of minus 5 ampere per division. Or, no sir, always the current is measured in terms of milliampere or microampere. Okay, fine. 11.76 into 10 to the power of minus 6 ampere per division. Either this is the standard unit or you write it like this. Don't write in between. Okay. If you are writing, kindly think about it. If you don't know how to convert in 10 to the power of 5 or 10 to the power of minus 6, better you go for this option. I recommend for my students to write like this. It is better, easy to remember. No need of by hearting the things. Clear? Thank you.